Hello, welcome to Maths with Jay. In this example, we want to know how long it takes a ball to get up to a height of 12 meters. We know that we've got constant acceleration here, it's just the acceleration due to gravity. We need to be careful here because we've got the ball moving up, but remember that gravity is acting to pull the ball down. So we need to make a decision about which way we're taking as positive. It doesn't matter which direction you choose, but you need to be consistent. So I think I'm going to take upwards as positive. And then let's have a look at the variables involved. So we've got a displacement of 12 meters. Now in this case, we don't know the initial velocity, but we do know the final velocity because we know that the ball is thrown up and it reaches a height of 12 meters, and when it gets to that height it stops moving for a moment before it starts coming down again. So we know that the final velocity is 0. And because we've taken upwards as positive, our acceleration due to gravity is minus 9.8. And we're trying to find the time that it takes the ball to get up to 12 meters. So in this case, we're not interested in the initial velocity. So let's have a look at our equations of motion for constant acceleration. And we're interested in the one that does not involve u. So it involves s, v, a, and t. So that's the fourth equation there. So the equation we're using is s equals vt minus a half at squared. So substituting in our numbers, we've got 12 is equal to 0 times t, so that's 0 minus a half times minus 9.8 times t squared. So be careful with your negatives there. Negative times the negative is a positive. So we've got that 12 is equal to 4.9 t squared. So t squared is 12 divided by 4.9. And square rooting both sides, we've got t is the square root of t is the square root of 12 over 4.9. And if we give the answer to one decimal place, well, it's 1.56 something like that, so that will be 1.6 seconds. So to one decimal place, it takes 1.6 seconds for the ball to reach a height of 12 meters.